Now this is the displacement for forced oscillator. Now we will compare the phase difference between displacement and driving force. So our next article is phase difference between this displacement and driving force. We will compare the equation of displacement, that is this x, and driving force F. Here we know that this is equation for displacement, let the equation number 1, and also the equation for force is F is equal to F naught e raised to power iota omega t. So these are the two equations, that equation for displacement is one and this equation for driving force second one. Now we will compare the phase difference between these two. For comparison of the phase difference, we will resolve this equation in cos and sine component, and also it will be resolved in sine and cosine, sine and cos components. Then after resolving, we will compare the real and imaginary parts of both equations. So first of all, we can resolve this F as F naught e raised to power e power iota omega t is cos omega t plus iota sin omega t. You know that e power iota theta is equal to cos theta plus iota sin theta. So I have used this formula. So it is F naught cos omega t plus F naught iota into F naught sin omega t. So this is the expansion of this force. So this is a real part and this one is imaginary part, real and it is imaginary part of force. Similarly, we will resolve this x in real and imaginary parts. Then we will compare the real parts of both equations or imaginary parts of both equations. So this is the equation in terms of real and imaginary part. This is equation for force. So this equation, let it be, this equation is 2a. 2a means it is extension of second number equation. Now we will resolve this x as iota f naught omega zm e power iota theta. Again it is cos omega t minus phi plus iota sin omega t minus phi, this one. So I am using the formula e power iota theta is cos theta plus iota sin theta, or we multiply this equation with this, that is iota f naught over omega zm into cos omega t minus phi, and we multiply this with this equation, this part iota into iota, iota square, that is minus 1. So minus into minus plus, okay, it is f naught over omega zm into sin omega t minus phi. So this is equation number 1a. So we will compare equation number 1a and 2a. That is, this equation is again consisting of two parts, two terms. First one is this term consists of iota and it is without iota. So this one is real part, this one is real part, or this is imaginary part. So as we know, in case of force, this is real, this is imaginary because it consists of iota and it contains iota, it is imaginary and it is real. Now we will compare the real parts. We will take the real part. Yes. So considering or comparing the real parts on comparing real parts of equation number 1a and equation number 2a. That is, equation 1a means equation of displacement and equation of force. So taking this real part, the real part of x is real part Re is this f naught over omega zm into sine omega t minus phi, and a real part of force is this one f naught cos omega t. So I have already only compared the real parts, real. I'm not going into the imaginary parts. So we will solve this article only taking any one part, either real or imaginary. So you will find the same answer. So in this book or in your syllabus, we are comparing only real parts. Now compare this real part of x, real part of force. The real part of x consists of sine function and it consists of cos function. So on comparison, we have to reduce either cos into sine or this sine into cos. So I will rewrite this f naught upon omega zm, that is real part of x, into sine. So I am writing this cos omega t minus phi and minus 90. You know that sin theta is equal to cos theta minus 90. You know that cos theta minus 90 is equal to sin theta. Therefore, I converted this sine into cosine. So this is sine become cos omega t minus phi and minus 90. Okay. Now, in real part of x, there is cos function. In real part of force, there is also cos function. Now, we will compare these cos functions and we will get the phase difference between these two. So, on comparing phase difference or phases of both, phase difference is omega t minus this, that is phase difference is omega t minus phi minus pi by 2. This is phase difference. So let this phase difference is capital phi, or it is omega t minus omega t plus phi and plus 90. So omega t cancel. So this is capital phi is equal to small phi plus 90. So this is phase difference, capital phi, phase difference between force, driving force and displacement. So you can also find same type of result by using or by comparing imaginary parts. So I am not solving for that. We will solve only real parts. Now, the next part is the variation of phase difference, this one, phase difference between x and f, that is capital phi, with driving force frequency, omega. So this is our next article, that is the variation of phi with omega. It is phi omega variation. Phi means this one is phi, capital phi. So what is phi? Phi is phase difference between displacement and force, this one, and omega is the frequency, angular frequency of driving force. So, we will show the variation by graph. So, we will plot a graph between phi and omega. So, what is phi? Phi is this phi, capital Phi is small phi plus 90, pi by 2 or 90 degree. Now, we can find the value for phi in terms of omega. So, what is the value of phi in terms of omega? Since phi or tan phi is equal to m omega minus sy omega over r. So, I have put this formula in the previous article where we are defining phi and amplitude. So, tan phi is equal to m omega minus sy omega over r. This is tan phi, and we will put the value of omega here and then find the value of small phi, and on putting the value of small phi here we can find the value of capital Phi. So, this is a variation or formula by which we can plot a graph. So, we will plot a graph by taking three values. Let there are three values. First, when omega is very small, that is omega tend to 0, and second part, when omega is at resonance, omega naught, or it is called resonance value, resonance frequency, and third, when omega is very large, that is infinity. 0 10 means very small and infinity means very large, and medium value is resonance value. So, we will find these three cases for omega and corresponding value of small phi, then again the value of capital Phi. Okay. Now, in the first case, when omega tend to 0, so when omega tend to 0, we will put here, it will become m into 0, that is 0, minus s by omega over r. So, when omega tend to 0, then tan phi tends to 0 minus infinity, because something upon 0 infinity over r, that is minus infinity, and phi become minus pi by 2. You know that tan pi by 2 is infinity, or tan minus pi by 2 is minus infinity. So, therefore, small phi is minus pi by 2 if omega tend to 0. If small phi is minus pi by 2, put small phi value in this equation and we can find the value of capital Phi. Phase difference is equal to phi, small phi, that is pi by 2 plus pi by 2 plus pi by 2 will be cancelled, answer 0. So, if omega tend to 0, then phi also tend to 0. So, this is the first value or first coordinate which we have obtained. So, in the first case, omega tend to 0, capital Phi is equal to 0. This is first value for the graph. Now, we will find the second value. Second value, when omega is at resonance, omega naught, and resonance value is s by m under root. You know that this is natural frequency or resonance frequency. So, put the value of omega as s by m here. So, tan phi become m into s by m under root, this one, minus s over omega is here, that is s by m under root. Okay. So, if you find over r, so it is s is cancelled with this, it is s m under root, s under root minus m under root and s under root upon r. So it will become 0, 0 by r is 0. So tan phi is 0, this means small phi is 0 because tan 0 is 0. If small phi is 0, then capital phi, it is nothing, it is small phi plus pi by 2. So it is 0 plus pi by 2, that is pi by 2. Okay. So this is second value. Second value is when omega tends to omega naught or resonance, then capital phi is pi by 2. This is second value. It is first value, it is second value or second coordinates. Now third one, when omega tends to infinity. So when omega tends to infinity, then what will be the value of tan phi? Tan phi is, what is tan phi? Tan phi is m omega minus s by omega over r. So when omega is infinity, it will become infinity into m, infinity, minus s by infinity, 0 over r. So it is infinity minus 0 means infinity. Infinity means very high. Upon r, again infinity, infinite. So tan phi is infinity, it means phi is pi by 2. You know that tan 90 is infinity. So when small phi is pi by 2, then what will be the value of capital phi? Capital phi is small phi plus pi by 2, that is small phi is pi by 2, pi by 2 plus pi by 2, that is pi. Okay. So this is third value, that is when omega tend to infinity, phi tend to pi. So this is third point. Third point, when omega tends to infinity, then capital phi is pi by 2. So these are three values of omega and capital phi. So we will plot the graph between this capital phi and omega. So omega has three values. Omega 0, this is omega is 0. At center, omega is omega naught, this one. And at high value, omega tends to infinity. So these are 3 points I have shown or I have marked on the x-axis because these are the values for omega. And the corresponding values for phi. Phi is 0, pi by 2 and pi. So it is 0, it is pi by 2, it is pi. It is pi, it is pi by 2. Pi by 2 means 90, 0, 90 and 180 because pi is 180. Now mark these points. When omega tends to 0, phi is 0. Omega 0, phi 0. This is first point. And second point, omega is omega naught, phi 90. Omega omega naught, phi is 90. So this one, second point. And third point, omega tends to infinity and it is pi. Now the nature of graph is just like this. It is not straight line, it will be the curve nature. So we can prove it by taking another points between these 2 points, another values between these 2 and between these 2, you can find that the nature of graph is like this, that is curve nature. So this is the variation, this is the variation between phi and omega. So is it clear? So we, in our next lecture, we will find such type of variations between amplitude and omega, velocity and omega, acceleration and omega, and so on. So we will discuss 4 or 5 articles like this. Thank you very much.